College Algebra, Topic 6.4, Applications for Systems. Number 2, we have a mixture of nickels and pennies that's a total of 48 cents. If there are 20 coins in all, find the number of nickels and pennies. Well, since we're looking for the number of nickels and pennies, we need a variable that stands for the number of nickels and pennies. So let's use X for the nickels and Y for the pennies. We know that when we add the nickels and pennies, the number will add up to 20 coins. So since X and Y are standing for the number of coins, we'll say the X coins plus the Y coins will equal 20. Because again, 20 stands for the number of coins, and we are looking for the number of nickels and pennies. Now furthermore, we know that the total is 48 cents. I'll write a new equation that'll keep up with the value. We know that for every nickel that we have, we'll have 0.05 cents. So this is the value of the nickels. Plus, for every penny that we have, we'll have 0.01 cents. And if you add up all the values of the nickels and the pennies, we want that to be a total value of 48 cents. Now we have a system of equations, two equations that are using the same variables, X and Y. Now I'm going to multiply this by 100 in order to move the decimals over twice. So we'll multiply this by 100 and we'll get 5x plus 1y equals 48. Now, using elimination, I'm going to move this equation, x plus y, underneath this one. X plus y equals 20. And now, I'm going to use elimination by making this a negative y. So we'll multiply all this by negative 1, and we'll get a negative x minus y and a negative 20. Now we'll add these two equations, and the y's will be eliminated. So we'll get 4x equals a 48 and a negative 20 is 28. Divide both sides by 4, and x is 7 coins. So we have 7 nickels. Now using substitution, 7 for x plus y equals 20. Subtracting 7 from both sides, we will have that y equals 13. So the number of nickels will be x, which is 7. The number of pennies will be y, is 13. Okay, next problem. Let's say Sensei wants to mix white chocolate that sells for $3.60 per pound with mint chocolate that sells for $7.20 per pound. How many pounds of each chocolate should be used to make an 80-pound mixture selling for $4.95? Well, we're trying to find how many pounds, so that means our x and y will stand for pounds. Pounds of, for the mixture of the white chocolate and the pounds for the mint chocolate. So we'll use W for the white chocolate, W our pounds for that one, and then for the mint chocolate. Now, since W and M are standing for pounds, how many pounds? We know that we have a total poundage of, let's see here, 80 right there. So we know that when we add these 2 pounds, they should be 80. Now, price-wise, we know that for each pound of white chocolate, it's going to cost us $3.60 for each of those pounds. And for the mint chocolate, it's going to cost us $7.20 for each of those pounds. Now, that's going to equal the total amount of pounds, which is 80. But then we're going to be paying $4.95 for those 80 pounds. So let's put a parentheses here, $4.95 for that. Okay, so now I'm going to multiply these two and get a total amount of the price here. So we'll have $3.60 times W plus $7.20 times M. And here we're going to multiply 4.95 times a total of 20 pounds. And that is going to give us, let's see, $99. Oh, $99. Okay. let me check that to make sure I multiplied that correctly. Oh, no, I didn't. So 4.95 times 20. No, times 80. That was the problem. Times 80. Okay, much more money than that. It's going to cost us $396. Okay. So now what I'm going to do to solve this, I'm going to use again my elimination method. To get rid of these decimals, I'm going to multiply everything by 10. So this will be multiplied, and this will all be multiplied by 10. So this becomes a 36W, this becomes a 72M, and this becomes 3,960. And then I'll put my WM, W plus M here, equals 80. Now I'm going to multiply all of this by a negative 36. This will give me negative 36W minus 36M, and then again the negative 36 multiplied by the 80 will give me a negative 2880. Okay, now we'll add these two lines and the W's will be eliminated, and we'll end up with 36M, and let's say 3960 minus my 2880. That leaves me with 1080. Let's divide both sides by 36. So divide both sides by 36, and we'll end up with M as 30 pounds. Now let's go back and get the W. Okay, so we'll put 30 pounds here, so we'll have W plus 30 equals 80. It's a bad looking 80. And we'll subtract 30 from both sides, and W will equal 50 pounds. So for the white chocolate, that's going to be 50 pounds, and for the mint chocolate, that's going to be, we're going to need 30 pounds.